Okay, let me see if I can upload some music for them to enjoy while waiting for the show to start. You can hear my voice clearly?
Yeah, very clear.
Mm-hmm.
Mr. Lee, very clear.
Maybe, Mr. Lee, you can try to share the PowerPoint first page to make sure that you know how to, share the PowerPoint.
PowerPoint here.
Yeah, that's good.
So
Quite
Full
good.
screen, full screen.
I like to use my, hang on, I'm trying to extend the view so that I can check everything. I'm using a 2 monitor actually.
Oh,
Okay. Can you hear the music?
Yep.
yeah. Actually, through the Google Meet, right, you can share the YouTube video as well.
Yeah, that's right. But I never upload to the YouTube.
Just share with you. Okay.
Yeah. But is this music, is it clear?
Okay,
Yes.
but your voice is clear.
Yeah, because I think because I never switched to the built-in speaker from my laptop, so therefore you hear the music actually through the microphone. So when I want to show later on, when I want to share some audio in my slide, then I have to temporarily switch off my microphone and turn to the built-in speaker from the laptop. I put a remark in my slide in order to remind me. Actually, I have to do this switching on and off, on and off. For Mr. Lim, the moderator, you will introduce myself to others, or you want me to introduce myself? You will introduce.
Yes, I will introduce. Yeah.
Yes. Okay. You have my resume.
Yep.
Okay. Good. Have you go through the slide?
Yes. I'll go to the slide as well.
Yeah. I might not use all slide because I just in case I just make more slide actually. It depends on the flow of my presentation.
Yeah, sure, no problem.
I just want to check the what is this RM? Let me see. You have this so-called the RME, then RMT and RME. What is that? What stand for all this?
RME stands for Mechanical Engineering.
ME is mechanical. R stand for what?
R is the degree program.
R is for degree. Okay.
Yeah. D for diploma.
D for diploma.
Yeah.
Okay. So the MG is what then?
Mechanical diploma. MG is mechanical diploma. DMG stands for diploma in mechanical engineering.
ME is material engineering then.
No, MT. A degree, they have a different coding. Degree start with RME, RMT. Diploma, we have another coding, DMG. Diploma, we don't have materials already. We only left electronics. We have DMG and DMR.
DMR. So MG is diploma in mechanical.
Yes, we are right,
So
Mr. Lee.
DME stand for what? Engineering? This electronic?
DME is phasing out already.
Oh, you don't have, huh?
Going to phase up lah. We are replacing with DMG already.
Okay, and the I can see this.
DMR, right?
MT, MT, T stand for what?
Materials.
Okay,
Materials
that's
engineering.
material. What about MH?
MH is mechatronics.
Okay, mechatronic. Okay, what else you have? Then you have MR. R stand for what?
MR is diploma in mechatronics. DMR.
Or MR and MH, both also mechatronic. But
yeah, one at degree level, one at diploma level.
Okay, okay. All right. So.
Mr. Ong, just to confirm with you, Mr. Ong.
Yes.
those who are outside TARUC, when they join with their own email, we still have to accept them, right?
Yes.
Okay,
I think
understand.
only you you're able to see their name.
Yeah.
I think all the email, I think even our students, if they say when they register, they are using their own Gmail or Hotmail or Yahoo Mail. When they join
Also,
Google Meet, maybe you have to accept,
Okay.
keep the accept. Because I think this is something a filtration process.
Okay. So I accept because I received quite a number of other TARUC email requesting lah. So I understand.
I think only you able to see those email when they join because you are the one who created it.
Okay. Thanks. Okay.
But because I think all the time the Google Meet extensions will help us to record down the academic as well. So I think should be okay, right? I think we can trace their name and we can trace their name.
And later in between I'll do attendance recording, no? In between.
Yeah.
Okay, so
I think it's about 10 already. Are we going to start or just hold on for a while? Because now we have about 50 something participants.
you have more than 50 already.
Yeah, 55 in fact,
Okay.
in the list.
Are they usually punctual to attend the online?
What you say? You want to wait for a moment or another?
I think we can wait another 3 minutes.
Because of jam? Just now I'm trying to join in, but is keep on routing. Is it because of the system is facing congestion or what?
No, I think it's out the email who are known from the TARUC, they may need to permission from the Miss Lim to access this Google Meet link. Okay, what I mean?
Or you have to access for those?
Yes. Yeah, those emails outside from TARUC official email, they may need to get the permission to access this Google Meet because this Google Meet is a service, right? Is provided by the TARUC official email.
Okay.
So it's a one step to security, one tail security to how to protect the privacy of the meeting.
Okay.
Mr. Koo is in.
Mr. Koo?
Cool.
He's in. Very good. Good morning, Mr. Koo.
Mr. Koo, can you see on your camera? see our old friend, Mr. Koo.
Our Dr. Choi Kim. Good morning. Choi Kim, how are you?
There are some lecturers from materials department as well.
Okay, they're most welcome. Yes, they're most welcome. Yes, Mr. Koo, yeah, I saw the name.
Hey, Mr. Koo is here.
Yes, Mr. Koo, how are you? Your mic is muted already.
Yes, correct.
Yeah.
Because I didn't on the mic.
Very good. So
Yeah.
we are both learning.
I think actually you will interfere with the talk. That's why I didn't on.
Okay, that's fine.
Yeah, okay, good. Morning.
Yes, good morning. Where are you now? At home?
Yeah, at home. At home. Yeah, look at that.
Okay.
Yeah.
So I think we should start now. It's already 5 minutes.
Okay, so welcome and good morning to everyone. Thank you for joining us for today's industrial talk. My name is Lim Jinxiang and I will be your MC for this session. So today we are presenting Injection Molding, What You Need to Know by T.S. William Lee Kin Wang. The talk is about injection molding and T.S. William Lee will present the talk by addressing the important issue in the real-world manufacturing industry, like what are the most concerned by the employers, what are the basic skills required, and what are the important manufacturing variables, and etc. So please be sure to pay attention. Before we start, let me explain how you can talk to us during the presentation. If you have any questions, please write them in the chat box. So we also have an active Q&A session at the end, so don't worry. Now, without further ado, I will introduce today's presenter, Mr. William Lee. Mr. William is an expert in metal and alloy industry. In fact, he was invited as a guest speaker at Mesolite in last November. Mr. William is a former hands-on practitioner, industry practitioner, and he's now a consultant, course engineer, and instructor with over 32 years of teaching experience. Mr. William currently provides training services related to manufacturing, and he has developed more than 150 technical courses based on his invented 5M learning approach. Now, please join me in welcoming Mr. William Lee. Mr. William?
Yes, okay. Thank you very much. Hi, everyone. I hope you're doing fine and staying healthy at home. This is William Lee here. And thank you, Mr. Ong, Mr. Lim, and also Dr. Lee for arranging this webinar session. And also thank you to the moderator, Mr. Lim, for the wonderful introduction. Okay, today I'm going to talk about 1, 2, 3, 4, 5 of the injection molding. Okay, so you can see my share wheel now.
Yes, can see.
Yes.
Okay, very good. So what is this 1, 2, 3, 4, 5? Actually, I'm trying to mention about one is for the one common goal from the employers, that is from your boss or your future bosses. And 2 is a crucial skill from the employees. 3 is a criteria from the mentors. 4 is a characteristic of the plastic material. 5 condition that you should know from the workshop. Okay, so without too much delay, then I'd like to go straight to this technical point. And first of all, I would like to just introduce you what is this injection molding process. Okay, so now in one of the injection molding cycle that you can see from the slide here, it consists of 4 phases. All right, 4 phases here. So that you can see. Yeah, I'm sorry about it because the simulation is supposed to move, and I apologize for that. I don't know what happened, why it doesn't move. Let's hang on a second. Perhaps I need to restart my slide again. Just hang on. Okay, so.
Hello.
Yeah.
Hello. Hello.
Yes. Okay, so here you can see that there are 4 phases here, and one is the clamping, and then followed by injection, and then cooling, and then the ejection, right? So as you can see from this injection molding process, so the first phase is clamping. So what happened with the clamping, that the 2 mold half here is getting approached during the injection phase, and the plastic will pump in to fill up the cavity. And then now the mold is under cooling. After that, the parts will be removed by opening this mold here. I will explain to you each phases from these 4 phases of the injection molding process. Okay. So during the clamping phase, here you can see that the mold is actually divided into 2 halves. So on this side here, on your right hand side, this is called the fixed half. The fixed half means that this mold is attached to the injection site, which is nearer to this nozzle, and this is a barrel. So whereas on the other half here, this is called the movable half. Okay, and some people call this as a B half, or some also know it as core site. So this is here, we can see this is a core. Core means that the mold is where you have the features where they are projected out. Whereas on the air half side here, this is a cavity. Okay, so cavity is a recessed area, whereas the core is a projected area. So during the clamping, these two more half, they need to come initially at a fast speed, right? Then when come to the closer distance, they will have to slow down just to avoid slamming onto the other half, and then you damage your mold. But I can see there is some imperfection from the simulation. As you can see, why? Because this ejector pin, they are supposed to retract back to the original position, but not to allow them to project out. So I think this is an error from the simulation program here. So otherwise, you can see that when the other half is getting close to this air half side here, you might slam this projected pin might crack when they hit to this half here. But anyway, this is a clamping phase. The clamping phase that when the mold is closed, then the machine have to build up this clamping force. Now, clamping force is trying to close the mold, whereas the injection force is trying to open the mold. So because initially the mold is empty, so you can see that there's no pressure inside, but the most is only the atmosphere pressure because they all fill up by the air. So when you try to pump in later, during the injection phase, when you try to pump in the plastic inside, you're trying to open up this mold because you build up the internal pressure. So therefore, clamping must build up the force to close the mold. Otherwise, the plastic might zip out, and that gives you some extra material. We call this as a flashing. So next is the injection phase. Under injection phase, you can see that you have three function here. Okay, three function here. Now, of course, you may not have the notes with you, but I want you to write down some of the keywords because later on I'm going to throw you some quiz, and I want to test you whether you pay attention or not. Okay, so under the injection, you have three function here. So one is to fill. You can see that initially the mold is being filled up by the plastic. So preferably, we don't want to fill fully. So you can see we still have some gap. So we just fill up loosely. The reason behind, because we want to allow some room space, because room space is important for the plastic to move during the second function, which is called the packing, right? So the purpose for packing is to fill up the unfilled during this first function here, okay? And another purpose for packing, of course, is to compensate for the shrinkage of the plastic. Because right now, plastic is under the molten condition. You know that when the plastic is solidified, it will shrink. So therefore, you need to pack out to compensate for this shrinkage. So when you pack, of course, you are trying to squeeze in more material, and therefore, you will build up a tremendous pressure inside the mold. Right, so this pressure we call is a cavity pressure, because this pressure will be exceeded inside the cavity here, and this pressure will try to open, will try to expand the cavity, and sometimes it can force the plastic to flow out. All right, so this is called the backflow. If the plastic from the cavity flew back to the runner system, that means you will end up with some short molding. So therefore, you need to, at the same time, you need to hold it. So hold is coming from your injection system here, whereby you need to prevent the backflow. So remember, during the packing, we only allow to have one way. So we don't want the plastic to flow back. Yeah. So everything okay, Ong and Lim?
Yes, everything okay.
Okay. So the second, now we come to the third phase here, and this is under the cooling phase. So here you can see what happened is that during the cooling, this indicate this is a water line, right? The coolant you can use, either you can use the water or you can use the oil. Depends on the what temperature that you want to apply to your mold. Okay, so during the cooling phase, it seems nothing happened in the mold system, right? But actually now the molds are under the cooling, all right? So you don't want to cool too fast, because if it cool too fast, that means that you are going to solidify the material too soon. And then when you open the gate, open the mold too soon, your plastic is still warm and they're still weak. So therefore, some of the injector may hit to the plastic body and causing some this ejector mark, which can be causing some reject because of the cosmetic issue. At the same time, during the cooling, so the this screw they will retract back. Okay, remember the screw can move in two motion. One is a linear motion. Linear motion means that the screw will move backward and forward. So that will provide some push to your plastic. And at the same time, when they retract back, the screw will rotate. When they rotate, means that they will try to build up another shot ready for the next cycle. Okay. So to build up the next cycle, we call this as a plastication, plasticization. And then now we enter into the ejection phase. So under the ejection phase, then the mold will open, right? When they open, then the parts will be removed, and then it will be knocked out. Again, I do not know why the simulation doesn't work. Let me, yeah, okay. So ejection phase now, yes, now it works, you can see. So then the two mold half will be separated, right? So initially, the mold, during the opening, the mold can move fast, but then later on will be slowed down. Right. You know, some people try to improve the productivity. They will try to adjust this speed here in order to save a few seconds maybe per cycle. Even though you can save a 0.01 cycle, can you imagine over 1 million shot? You actually can save a lot of time. All right. This is to optimize the molding process here. So you notice cooling just now. At the end of the cooling, then we come to this ejection. And here you can see that the screw has been retract back. Now they build up another next shot here and ready for the next cycle to happen. So the process will keep on repeat and repeat again. And here, after the 4 phases here, you complete 1 molding cycle. Okay, so now I want to show you a video. All right, just to recap what I have explained to you. And this video is presented by SME, stand for the Society of Manufacturing Engineer. Let me just hang on a second. Let me just switch it to the another speaker so that you can hear clearly. All right. So.
Injection molding is the most common method of producing parts out of plastic material. The process involves injecting molten plastic at high pressure into a mold shaped in the form of a part. Once this plastic cools and solidifies, the mold opens and the part is ejected. Injection molding is an extremely versatile process that can produce parts with holes, springs, threads, hinges, and undercuts in a single operation. Injection molded parts can be simple. Plastic cools and solidifies, the mold opens and the part is ejected. Injection molding is an extremely versatile process that can produce parts with holes, springs, threads, hinges, and undercuts in a single operation. Injection molded parts can be simple or complex, and can be solid, foamed, reinforced, or filled. They can be small, or large, thick or thin, flexible or rigid. Injection molded parts also lend themselves to endless decorative effects. They can be polished, textured, hot stamped, plated, colored, or clear. No other manufacturing process offers the range of capabilities injection molding provides. Injection molding machines range in size and complexity from desk-size units up to machines the size of a small house. All injection molding machines are a combination of two systems, an injection system and a clamping system. The injection system heats the thermoplastic material to its appropriate viscosity or flowability and then forcefully injects it into the mold. There are two types of injection mechanisms: the reciprocating screw, which is the most common, and the two-stage screw. The main parts of the reciprocating screw injection system are the hopper, a reciprocating screw inside an externally heated injection barrel, a hydraulic motor, and an injection cylinder. Resin material is fed to the injection barrel from the hopper. These hoppers may be filled manually or vacuum-fed automatically, and often have dryers attached to the top to remove the moisture from the material. As the resin enters the injection barrel, it is driven forward by the rotation of the screw, which is powered by the hydraulic motor. The resin plasticizes or melts as the turning screw drags it towards the nozzle end. This is referred to as drag flow. Drag flow causes the polymer molecules to slide over each other, creating frictional heat, which melts the material. External heating bands provide additional heat to the injection barrel. The heating bands bring the material to its final temperature and compensate for the radiation heat loss. The temperature is controlled by 3 thermocouples in the barrel and 1 in the nozzle. The screw consists of 3 zones. The first zone, which is 1/2 of the screw, is called the feed zone. It has a constant flight depth, which forces the material together and rids it of air. The second zone, called the melt zone, has a decreasing flight depth, which reduces the plastic volume. This causes the plastic molecules to rub harder against each other, plasticizing the material. The melt zone leads to the third, or metering zone. The metering zone has a constant flight depth much smaller than that of the feed zone. This section acts as a pump. The tip of the screw has a one-way valve which lets the material flow only towards the nozzle end. The force of the plasticized material pushes the screw back as it turns. This builds a chamber of plastic in front of the screw. When enough material for the injection shot is melted, the screw stops and pulls back to decompress the material. For injecting the material, the one-way valve closes as the screw is hydraulically pushed forward by the injection cylinder. This sends the molten material through the injection unit's nozzle and into the injection mold. The primary speed and the injection pressure, called the packing pressure, is high, usually around 20,000 psi, but sometimes reaching up to 30,000 psi or higher. A secondary lower pressure is applied shortly after the initial injection. At the time of injection, the material's temperature ranges from approximately 320 to 600 degrees Fahrenheit, or 160 to 320 degrees Celsius. Once the plastic solidifies, no more pressure can be exerted upon it in the mold. The reciprocating screw then begins to rotate again, melting material for the next shot.
Okay, let me turn back to my video, my camera, and also my microphone. Okay, so I hope that you have enjoyed the show just now, and that explained to you the overall view of the injection molding cycle and how the injection system works and how this mold is operating inside the machine. Now I want to throw you this quiz here. Okay, so this is the quiz number 1 for this morning session, and if you try to log in to this address here, that you can try to fill up and then submit to me what is your answer, right? So at the same time, let me type out for you. You can also use a handphone actually if you want. Okay, so on GM HQUIZ. So that's quiz number 1. So okay, I already posted out. This is the link where you need to write in your answer and then submit to me. Okay, the question is which action is not included in the injection phase? Remember, we have 4 phases under one molding cycle. Okay, so and let me try to also share with you what are the response from your side. So do some exercise now. So let me turn it to okay. So I'm going to turn it to my form. Once again, so quiz number 1. Yeah, okay, it's coming in. I can see the result is coming in. That's very good. Thank you very much for your response. Okay, so let me see if I can. Okay, so here you can see 44 responses now I have. Okay, so which action is not included in the injection phase during the molding cycle? So we have, okay, yep, 58. Okay, please, I need more. So you have altogether 100 attendance today. Response 61. So remember, we have 4 phases under one molding cycle, and I'm talking about the second phase, injection phase. Just now I mentioned consists of 3 functions. So here, which function is not under the injection phase? Okay, you are allowed to change your answer if you think that your first answer is incorrect. Just want to make it that you have catch what I'm trying to inform to you. Okay. So how many? 69. So please do some exercise. Okay, log on to the link that I have provided in the checkbox. Which action is not included? Okay, I can see that now majority of you selected number 1. All right, so 77. Okay, so it's more than 100% already. So more than 50, majority of you selected the answer number 1. So excellent. Excellent. That is correct. That is correct. So the injection phase should include only 3 functions. So, but the question asks you which function is not included. All right. Okay. Excellent. All right. Very good. Okay, I think that's all. I have enough already from your side here. Thank you very much for your response. Okay, so therefore the answer should be number 1, ejecting. Ejecting is not included in the injection phase. Okay, so for injection phase, you only have first is filling and then packing, followed by ejecting. holding, and these are the three functions. From the video just now, you have seen that we can also make many types of injection motor parts. Here you can see that we go back to my slideshow here again. So, okay, so we stop conducting this quiz test already. Here you can see that we can supply these injection motor parts for the electrical. This is a connector for electronic use. And the plastic can also replace the metals. Nowadays, you can see that some of the high performance plastic, you can make it as an engineering component. In this case here, this is a gear. Or you can also supply for some of these implants used in the prosthesis and also the medical healthcare product. And of course, nowadays, plastic become more and more common in the automotive vehicles here. They replace some of the metals because the trend for the car is going to be a lighter in terms of the fuel consumption. Of course, the designer is aiming to design a car with a less fuel consumption here. So there are many applications of this injection motor part. All right. So therefore, we have also plenty of a technical career opportunity in the injection molding company. So upon your graduation, you can try to work, apply some job. So what are the posts available in the injection molding company? We are talking about technical career here. Of course, you can work in the R&D section. You can also work as a designer to design the parts, and that can be also in the project team. And tooling side, you involved in taking care of the injection mold, and also doing the production running. And there are also maintenance because in the injection molding process, you involve a lot of machinery and the tools, and could be also involved in the quality control to try to detect some of the reject and failure analysis to check some of the problem issue. It can be happen to the design or to the molded parts. And finally, you can also involve yourself in the technical sales or technical marketing or the procurement. For example, you can sell injection molding machine, and it will be much better if you have some of this injection molding knowledge so that you can convince your customer to purchase your product. Okay, so therefore, if you are fancy to apply for a job in a technical career, now I want to go into the second session here. Let me talk to you, introduce to you what is the common goal from the employers. Now, in the view of this COVID-19 outbreak here, I can see that in the future, it will be a bit more difficult to find a job. Not to mention about we have also many unemployed graduates. Okay, so therefore, you can expect it will be a bit difficult to find this job here, but then therefore it's good for you to know what the boss thinks in order to find a fair deal here. I think in the market now, we have a lot of unemployed graduates from the local university. And don't forget that there are also many others outside here where they have also a diploma and a degree qualification. But why we have so many unemployment at the moment? According to the statistic, at the end of last year, we have about 500,000 unemployment. And then out from 500,000 unemployment, 60% are the youth. So I think the skill mismatch, which means that the skill and the knowledge obtained by the students compared with the qualification required by the industry, which is not the matching, and this is a main cause of the unemployment now. So therefore, the common goal from the boss here, you can see that because the boss is an investor, so remember, the employer is an investor. They invest their money in the building, they invest money in the machine, invest money in the mold. So they only have one goal in mind, that is to make the money. So that is to make the profit. So therefore, if you want to apply a job, of course, you have to help them to make the profit by offering them a solution, how to reduce the cost. The boss might ask you, hey, I want to hire you, but how you can contribute to maximize the profit for the company, right? So of course, they won't ask you directly, but of course, you have to impress them. So therefore, what is the best option to reduce the cost? Here I show you some of the solution here. So there are some people who believe that to hire the cheap labor. And do you think that this is sustainable? Especially now we learn from the COVID-19, whereby we know that by paying them too cheap and they're housing them in the congested quarters. So this might pose the risk to the society problem and to the healthy concern. Right. So, and furthermore, because of the influx also, it has dampened our wage growth. So ordinary Malaysian nowadays also cannot ask for the higher pay because they compare, some bosses, they compare the cheap labor cost compared with the ordinary Malaysia. But I think this solution is not the long-term solution. All right. So, and therefore the another solution is you can think of to reduce the overhead, for example, some utility costs in electrics, water bills, electric, gas bill. But if you want to run a process, I'm not sure whether this can bring a great impact or whether it can save significantly or not. So, or you can also think of to increase the production. To increase production means that you have to install more machine and hire more people. Or maybe produce advanced goods instead of making some ordinary or commodity parts. For example, in this helmet here, this is just a cheap helmet. Maybe you can think of to make some advanced goods such as this fancy helmet here. It could be some built-in headphone or built-in speaker, right? I think in the future we should also look at this solution here rather than you make the commodity parts where you cannot compete with those products produced from the third world countries compared with the Thailand or Indonesia, Vietnam, or from China. They're rather cheap. So another solution is to improve quality and productivity. And of course, I highly recommend that this is the best option. Improve quality and the productivity. Whether if you're still making the commodity product, so reduce the reject, that means improve the quality. And how do you improve the productivity? There's a difference between improve productivity and to improve the production. So you have to know how to differentiate these two. These are two different things. So let me explain to you what is this productivity and also the production. Assuming that you have a plant here where I have 6 unique injection machine and you have hired 6 operator and one will look after one machine. Okay, so the definition for production is the total output of a molding plant during a given time, whether per hour, per day, or per week. You measure either in terms of the molded piece in the amounts of plastic converted, per tons, per days, per week. How do you convert them? Right? So for example, let me see, from this plant here, you can produce 3,000 parts per 8-hour shift. Let's say one shift you run 8 hours. If you're running non-stop, 24 hours, meaning that is you just times 3, so you get the 9,000 parts per day, right? Per day is 24 hours. If you base on per shift 8 hours, so here you produce 3,000 parts. Okay. And what about productivity? So productivity is defined as a total output of a molding plant per floor area and the number of operators required. So as a rule, the better the machine you use, the more the methods you use to operate and the plant as a whole. And if you use fewer operators, so the higher is called the productivity. So for example, here you have one machine, one operator. And here we say that the output is, let's say, is 120 parts per hour, right? So that means based on one machine, one operator, you can produce 120 parts. Now here, if you compare the productivity from this plant here, of course, obviously, you have to compare fairly. So here you have a 6 machine, 6 operator. Here I only have a 1 machine, 1 operator. So how do you convert? If you base on 1 machine, 1 operator, how many parts per hour? Okay, so I want you to type in again, try to work out. If you have found the answer, type in the answer. So what is the productivity from this plant here? So how do you work out? Remember, based on one machine, one operator. So we have to compare them equally. Right? So how do you work out? So you know that you have 6 machine here, 6 pair here actually, one machine, one operator, you have 6 pair. Here only I have 1 pair. Okay. Yes, we have Huang is coming in and the Hao is coming in 62.5 parts per hour. Yeah. How do you get 62.5 parts? So it's 3,000 divided by 6 first. Okay. 3,000 divided by 6 and then divided by 8 hours. Because here I'm asking about the unit. That's correct. That's right. So we have from McLaren. Oh, we have a Formula One fans here. McLaren. Okay. So McLaren give clear details. 3,000 divided by 8 hours divided by 6 pair. You got 62.5 parts. So now you can see 62 compared with 122. Obviously, here is running much better, higher productivity, right? So there are better efficiency here. Okay, so I hope you understand how to work out and what is the difference. So let me show you one example here. Again, this is a plant A here. I have 4 machines and you're using 4 single cavity. Single cavity means that every one shot, you only produce 1 part. Okay, and then you have 4 operators. In this case, I just rated here based on the earlier output, 120 parts per hour per operator. So therefore, in this case, the output, now you have 4 machines, 4 pair already, all right? So therefore, based on 120 part, 120 times 4, okay? You got 480 parts per hour. Do you know how to work out? If you already know the unit here, 120 parts from the earlier slide, so I have a 4 pair here, right? So 1 pair contribute 120 parts per hour. So you have a 4 person here, 4 machine, 4 more. So I have 480. Okay, so I hope you understand how to work out. Now I compare with another plant B here. Here I have 1 machine only, and I have 4 KVD more. 4 KVD here, you can see that 1, 2, 3, 4. 4 KVD more means that every 1 shot, 1 cycle, then you can make 4 parts. And here I engage 0 operator because I use a fully automatic with the help from the robot here. And let's say if the output is still the same, but I'm only using 1 machine and there's no operator and only 1 mode. So you can see that now plant B compared with plant A, and this is 4 times better productivity compared with the plant A. All right. Again, you can also use automation. If you want to further improve the productivity, you can use automation, apply at the other fields such as a material handling system. How do you fit in the plastic to machine? And also how do you handle the part remove and storing the molded part to improve the productivity? Okay. All right, next I want to also show you another example here. Now that you know that the productivity from the earlier example here, okay, is plant B, where you can achieve the 4 times better than plant A. So assuming here how the time allocate for mold is 40 hours. So they mean from 1 machine, I give you 40 hours to run this order. So when you want to install the mold, let's say it takes 6 hours. And installation include, first you have to mount in the mold in the machine, then you connect all the pipeline, and then you heat up the mold. So you have to warm it up, and then you run it. After you run from a few shots, warm up, then you can run it on the full cycle with fully automatically. And also include here is also dismantle. After you finish the order, you still need to take out. So you need to also disconnecting and remove the mold and then to get the machine ready. So these are all included under this 6 hours here. So that means to say to install and to unload, it takes 6 hours. So that means the total hour allocated is only 40 hours. 6 hours is actually non-productive. So therefore, assuming that all pieces are good, no reject, acceptable. So how do you calculate the efficiency? So here you can see 40 hours minus 6 hours over 40 hours. This is a total allocated time. And you have wasted 6 hours for the non-productive activity. So 40 minus 6 divided by 40 hours, and what do you get? Times 100 if you want to convert into percentage. Okay, so can someone work out for me? What is this? 85. Yep, very good. Nicholas, very fast. 85% efficiency here. So assuming that only 90% products are good, so they mean 10% are rejected. Okay, so the net efficiency in this case is therefore from 85% here, then you take off another 10%. That means 0.85 times 0.9, then convert back to the percentage. You get 76.5% efficiency. So again, efficiency can also help to improve their productivity. How? By reducing the reject. Okay, so here, if you have a more reject, means that you will end up with a less value from 90%. Let's say in case if you have 30% reject, you only have 70%. So they mean multiply with the lower value, you will end up with an even lower percentage of this efficiency. Okay, so another way for you to help the employer is to reduce the reject. Okay, but then you have to understand what caused the reject. You still need to go back to the basic to solve the problem. So therefore, you know that the bosses, they don't want to waste their money, right? When they invest in you, they would like to ask from you, and what are they looking at from this fresh graduate? And what can you offer to the new bosses? So here I have listed the three skill set here, and then I would like you to check which skill set in terms of the priority is important for you to secure an employment opportunity. Could it be a personal skill, a working experience, and education qualification? Right. This is my second quiz. Okay, so I've given you this second quiz here where you need to find out, and this is just, don't treat it as a test, don't worry, it's just a survey only. I want you to rank them, which one is more important in the order of priority. For example, one means that this is more important, second important, or the third important. So I have three skill set here, all right, and then I give you the 1, 2, 3, 4, 5, 6 combination. Okay, again, please go to the survey. Oh, okay. Yes, thank you, Lim, for typing out the link for me. Okay, let's go to this survey here and check whether you have get it right. So, okay, I can see response are coming in. Okay, response are coming in. Let me share with you some of the response here. How do I stop sharing? Which one is more important? Yep, you can see the result. Okay. 40%, 25, majority are selecting C. Work experience is ranked number 1, personal skill number 2. Yeah, it looks like work experience. A lot of you believe that work experience is ranked number 1. Work experience. 25. Personal skill is 24. So now it's between C and F. C and F. Look at the trend now. It seems like a lot of people prefer C. Yeah, a lot of people. So majority of you prefer C, and some believe the second one B. Yeah. Okay, so I can see the trend now already. So it looks like you prefer number C. Work experience is ranked number 1. All right, that's fair enough. Okay, let's go back to this again. All right, so it's a very subjective. I can see that a lot of you prefer this personal skill, which is a rank number 1. All right, so you prefer F, and then the second one is a rank is a C, working experience. Now, what I can tell you, the criteria used by today HR practitioner when they first interview their fresh graduate, what do they care about? Now, don't forget that if you are comparing with those who are applying the same job here, and there are a lot of people who are also having this same academic qualification. So, but I can share with you some of the my survey is when I deal with these people here, and they told me that, and this is the ranking. Let me check. So this is a criteria used. So they will first check your character, all right? And then they will ask for they will test your communication skill. So these two are under the personal skill, okay? And then they will ask you the working knowledge, and they will check whether you have a job experience. And this two is actually checking whether you are work ready. And only final one, they will check with your education qualification. So this is what, according to some of the manager in the industry, they told me. All right, so this is for your reference. Okay. Now, what I can see from this survey here, you know that the employer will prefer. Well, some of you say that the working knowledge can be a priority, but what if you are without the working knowledge, and what if you never worked before, and therefore the personal skill is actually still ranked number 1 here, because they find that if you have the right attitude, then you have gained the opportunity to work and then to move on. So this is the how they rank it. And instead of the education qualification, you have to check that nowadays to own a diploma and a degree is not the must-have, but you need to have. There are a lot of people, there are a lot of unemployed graduates outside, they have the similar qualification. And if you fail in these two conditions here, some bosses, they don't even bother to ask you. And just to quote you one example here, my daughter, and she told me that when she finished the study, then she told me when she applied the job, they never ask her the education qualification. And she seems a bit upset because she tried very hard to study. And even though she scored a first-class degree, the bosses never ask what is the result that you have achieved. But they just want to see your attitude, your personal skill, and whether you have a work readiness. So here the difference between working knowledge here means that if you have been exposed to the working environment before, whether you have this so-called the team building, teamwork, okay? And job experience means that refer to the skill that is relevant to the vacancy that you are trying to apply. So this is for your information, okay? Now, of course, not everybody is perfect in this case. So therefore, if you do not own all of this skill set here, then you should set a priority. Right? You should set a priority, and how do you improve a certain skill which you think that is more important. For example, I've seen some employed graduate, they claim that my English proficiency is not so good. Now, I think to me, if you want to apply a technical job, I think the language proficiency might not be very important if you compare with the service industry, right? So in this case, if you want to work in the injection molding company as a technical employee, I still find that technical skill is more important, right? For English proficiency, of course, if maybe you are no good at this time, but if you're given the opportunity for you to mix around, for you to talk with the people, talk with the colleague, maybe you can improve in the later part. So therefore, what are the skills are important? And this will bring me to the second session of today. And we talk about the crucial skill now is from you, right? From the employee, not from the bosses. So I want to explain to you what are the employment boosting skill here. Now that we know that quality and productivity is very important. So the boss are concerned about quality and productivity. But how do you improve quality and productivity? Now, regardless whether this is a molding or die casting or the extrusion, you know that this is very important. So technical skill is still very important. So we have a hard skill and a soft skill. So I think the soft skill normally refer to the personal skill, whereas the hard skill refer to the hands-on skill. And how do you acquire this skill? You can acquire those skills from the courses, some of the training courses, and courses can be divided into technical and non-technical. But more precisely, for me, technical can also be divided into a technical hard skill and technical soft skill. What is a technical hard skill? I say here, technical hard skill enable production. For those who can read this Mandarin, you can see that technical hard skill enable production. That means that you can produce a part. In this case, they involve the use of the machine. You must know how to operate machine, operate the mold, right? And maybe to use some sensor for this production here. And also, if you have some defect, for example, in this case, this is an unbalanced cavity field. Maybe you have to learn how to use the insert, or maybe in the future, maybe you also learn some digital skill, how to command the robot to perform a specific task. These are under the technical hard skill. Okay, by using this machinery and the tools, so it allow you to start to produce some part. But this is only a shape, as I said, that to produce a part. The part looks like the shape of the product. But whether this product is reliable, is durable, can last longer or not, and this talk about the performance of your part. In this case, technical soft skill, where they teach the science and insight on how to make a good part, right? So this part must be achieve the specification set by the user, by the customer. And this is the difference between soft skill and the hard skill. So in short, we can say that soft skill is to learn the theoretical side of the this technical learning, right? So theory is, of course, some people say that to learn the theory might not be applicable, but it's good to study theory. The only thing is that you have to focus. This theory must be applicable to the job that you are using. Okay, so here we teach the science and the insight. So I find that the technical soft skill is a missing link in the technical learning. All right. So you can see that many institutes, they teach the people how to operate CNC machine, learning this software, how to operate the machine equipment and the tools. But this is to say that the knowing how to operate the machine is still not enough. If the rejects are still high, all right. So you must learn how to produce a defect-free product, because we want to improve quality and also productivity. So if you want to ask for a higher pay, unless you can help the boss to solve the quality and the productivity problem. And the bosses, they like to hire a problem solver, which means effective troubleshooter. So it is important therefore, for the existing future technical employee to learn the inside of the manufacturing details. If you ignore the details, it will jeopardize the overall product quality and the productivity, right? According to John Wooden, do you know who is John Wooden? He's a very famous basketball head coach from the California University. He said, it is the little details that are vital. Little things make big things happen. Usually when you apply the job, you may be assigned to look after a certain specific task. But I find that a lot of other people, they tend to ignore other factors, which they feel that, for example, like the details of the design, details of material, details of the mold making. So, and they thought that this is not their scope of duty, which I find that this is wrong, because to make a quality part, it depends on many manufacturing variables, which I will explain to you in a short while. Okay. So I believe, therefore, manufacturing should be regarded as a science. It is not a magic. So you can see that magic means that this is our famous cartoon to depict our Raja Bomo. And this differentiates what is the traditional workers and the scientific workers. So if manufacturing is a science, we call this as a scientific manufacturing. We should treat it as a science. For scientific manufacturing, you require scientific workers, right? The difference between two is scientific workers, they're always based on fact and data. So they just behave like a doctor. For a doctor, they always study the prior history. They're based on data. They will inspect you before they give you the solution. They give you the medical solution. So how do you build up this knowledge here? The technical soft skill based on scientific and logical reasoning. It will be useful to complement the hard skill practice, not only by using the hard skill. Okay. So I'd like to show you some case study here. What is between the hard skill and the technical soft skill? In this case, you can see that a tool maker or mold maker, he make this plastic mold here. You can find that this is a crack, experienced a crack after they have been used in a short time. So and this mold maker always struggle. He said that I cannot produce a good mold, even though he already invested in a multi-million CNC machine. So actually what's wrong with this case here, from my study, from my investigation, it was due to the improper hardening. Because normally when you use a tool steel as a mold, you need to harden the mold. Right, so machining is considered a hard skill, but machining can produce you only the shape, and this looks like injection mold insert. So it looks like an insert, but then can it be last longer? So it depends on how do you bring out the performance of this. Depends on the hardening. Therefore, heat treatment is also very important to know, because the heat treatment will bring out the best of this material here. For this second case here, you can see that this is a molder. So the molder complained about the weld line. Here you can see that the weld line on this car panel here. And here we have a 4 gate here. The weld line, how they form the weld line? Weld line is because you have a joint of these 2 male streams. So the male coming out from the gate here, and they join up together. Right. So in order to strengthen or to improve this weld line, so and this molder trying to enlarge the sprue size. You know what is the sprue size? So this is the sprue. Okay, so this is the sprue. All right. So if you improve the sprue, means that you pump in, you allow more this volume flow. So with the more material fill up, of course you can heat up, and then you can lower down this appearance of this weld line. But at the same time, after he enlarged the sprue, combined with the high heat melting, then he experienced the nozzle leaking. In this case, then he experienced a short fuse problem when he lower down the melt heat. When you lower down the melt heat, it means that you do not have enough heat, then you have a short molding. Instead of solving the old problem, now you create a new problem. So weld line may be solved, but because you lower down the melt heat, enlarging the sprue size, so you end up with the short fuse problem. So you have to therefore understand some of these technical the science behind this process. How do you tackle the problem by looking into the inside of this molding process? And this is case number 3, where they conduct this DOE stand for the design of experimentals. Here they conduct, the DOE is actually a statistic methodology where they want to find out, to build a process window by selecting, determine the right parameter here. The results show them to use the higher melt temperature and the hole pressure, which is makes sense. But then it's also at the same time ask them to feel slow. Does it make sense? It doesn't make sense, right? Because if you feel the part slow, that means the temperature will cool down. When you cool down the temperature, by the time when the two melt stream meet each other, you can see the visible well line, right? So that is to say, you have to again understand the inside of this process in order to choose the right parameter, to choose the right factors. Otherwise, some of these result it will give you a logical reason. Okay. So my advice, therefore, you have to work smart and not harder in order to deserve a higher pay. Okay. So when you have this problem, of course, it relies on your skill to solve the problem. So to me, solving the problem, you have two ways. And one is to fix the problem, but this is just a temporary measure only. To fix it, we say that fix it means that you have to do it fast. Why you need to do it fast? Because you have a deadline to make. And usually this is what happened in the factory, in the existing manufacturing. And here, from my observation, I find that the existing manufacturing culture here is where people always entertain this reject. And then you have to rework, and then you have to replace them in time. This is just a fix it temporary, okay? Which is not sustainable to me, because the problem still happen again. If you want to solve it forever, all right, so we have to change this 3R. What is 3R? Reject, rework, replace. Not to say Ronaldo or what you call Ronaldo and so on, Robinho, but reject, rework, replace. So the new 3R should be, you have to conduct a research, you have to review the process, and maybe you need to re-engineer it. Okay, so therefore, to solve the problem, you need to solve it patiently. You have to follow this step. And then you have to analyze carefully, objectively, and then you have to apply the science as a common sense, logically, right? Obviously, and this way of solving the problem, you can remove the problem forever, but it takes a longer time. In order to conduct the research, you must have a strong fundamental knowledge. And this is where learning from this technical soft skill by studying the science and insight is very important. So remember, employer always prefer to look for the troubleshooter. So you need to back up, you need to equip with this necessary skill and the knowledge to become a very, very resourceful company. So chasing a degree or the diploma is not enough. You need to add value, right? By attending some of the courses, by doing extra reading, and that will add value to your academic qualification, and that will secure you the job, and that will make you to stay in the job, and that will make you move up to the top of the job, right? That's my advice. Okay, now quiz number 3. So, and Lim, can you type in quiz number 3 for me? So, and the first step of effective troubleshooting strategy that a smart worker should apply is what? Okay. Yes, please check at your checkbox there, so you can type in your answer. What do you think? The first step for you to effectively solving the manufacturing problem, troubleshooting strategy, you must set the right strategy. Okay, now we want to become a smart worker. So, okay, so let me check. So let it go. See that the whether you have the right answer. And this is quiz number 3. Okay, very fast. We have 40 responses. Okay, majority of you confirm the defect. Second, timely documents or process data. Number 3, establish traceable molding process. It looks like the trend is going to be a question that the answer is number 1. I'm not sure yet. I'm not saying that the answer is number 1, but I can see that the majority of you selected the answer number 1, confirm the defect. Okay, so that's the trend. Go back. Okay, I think to tell you the answer, actually the answer here is number 3, right? Why? Because if you go for the defect, by the time you confirm the defect, that means that the defect has already happened, right? So it will be better for you, before you wait for the problem to happen, you need to establish a standard process first, right? Based on this standard process, you have already all the data. And this standard process assuring you to produce the acceptable part, all right? So, and then when the process is ongoing, then you have to record all the data. By the time when the defect happens, you confirm what types of defect. And this defect is caused by what parameter. So therefore, as an effective troubleshooting strategy, you don't wait for the defect to happen. You have to establish this traceable. Traceable means that you already have all the standard data, standard parameter. When defect happen in the later part, then you compare all these parameters with your standard process, right? And this is to say that you don't wait for your car to break down, then only you send to the workshop to repair. You have to maintain your car properly first, right? So before you wait for the major problem to happen. So the effective, actually the effective, I would say that the step for you to go for this. So first step is to establish a standard traceable process. Then you have to record the data. Later you confirm the defect. If there's a defect happen, you have to investigate it. And then after you investigate, then you compare with the data from the earlier one. Okay, and then you revert to the original data. After that, you run again, you record down the data. Okay, so then you reconfirm, and then you have to document. Documentation is very important, so that you have to be aware. Okay, now we move on to the number 3 section here. So I'm running a bit time of our times, so okay, we have to move fast. So how do we train our people? In this section, I would like to share with you how do you find a good mentors. How do you learn? Is it on-the-job training or is it off-the-job training? Now, statistics show that what we learn from the on-the-job training is either you learn it alone. That means you receive the order from your superior. They give you the order. There's no guideline here. All right, you just get the order and then you have to work out by yourself. Okay? So this is the learning alone on the job. You're already in the job. Okay, so this way of learning without a guideline is actually not so effective, because provided if you are knowledgeable enough, and sometimes because of this reason you may be too busy, so therefore your learning is not focused. Okay, the other way is with a guidance. With a guidance means that you have a senior to refer to, right? But again, this is also a complicated learning process. Why? Because it's involved the human factor. Because the senior, you do not know whether they're willing to teach you, whether they are capable to teach you, whether they are free to teach you, and whether they know how to teach you, right? So I think both way is also not effective, because both processes take times for you to acquire this knowledge and the skill in the shortest possible time. So therefore, off-the-job training means that you have to look for you have to attend a certain training classes, which is a more focused. So if you believe that training is a profession, so you must find a trainer or the mentors who can develop a systematic training, right? A more structural learning process. If you pay focus, attention, 100% attention to this training, so of course you can catch up, you can acquire this knowledge in the shortest possible time. So the purpose for training is, of course, to acquire the skill and the knowledge. So whether it's a technical skill or whether it's a non-technical. According to Terming, do you know who is Terming? Dr. I think the full name is Dr. William Edwards Terming. Actually, he's an American. The American who taught the Japanese quality. It sounds a bit strange, but it's not surprised during that time, because this is happened after the World War II, when the Japanese was defeated by the American, and Terming went to Japan to taught the Japanese this quality concept. And Terming always emphasized training, because he believed training is to achieve consistency, to help reduce variation. And he believed training can build a foundation of a common knowledge, and training allow you to understand your roles in a bigger picture, especially in a manufacturing environment. So in manufacturing, it's a teamwork. You cannot just focus on your own job and your own section. So it must be a big picture. You involve others' team, others' variables. So of course, training also encourage staff to learn from one another, to understand others' problems, and then you give it a culture and environment for effective teamwork. Right? So therefore, a good mentors, to give you 3 criterions from the mentor, is a good mentor is qualified to train in terms of the experience, in terms of the skill, in terms of the knowledge. All right, and then he must be willing to train, and he must know how to train. Okay, there are some people who are qualified but they do not know how to train, which is also not effective. And there's some who are qualified but they are not willing to train. They don't want to share with you with the knowledge and the experience. You cannot acquire this information, right? So these are all interactive. So therefore, a good mentor should give these 3 criteria: qualified to train, willing to train, and know how to train. So there are many training providers next time when you are in the industry. So employers, of course, they refer to this HRDF. You can log onto the website where there are many training providers registered with the HRDF, stand for the Human Resource Development Fund. Okay, and here is also another professional body for the engineer and for the technologies. This is from the Malaysia Board of Technologies. You can log in their website to find out some of the training provider and their training courses. And my company is actually registered with the MBOD and registered with the HRDF. And you can also log on to my website. Okay. And to date, my company actually developed more than 150 topics involved in the precision engineering, that is talk about the mold and die, and then we have injection molding. I have 40 topics. Total one topic, it takes about 4 hours. I have metal stamping, semicon, die casting, forging, and material engineering. So you can always log onto the website if you're interested to participate. Okay. Now, of course, these are chargeable, but if you're interested, maybe next time I can give you a much better discount if you have this continuous learning unit to organize some of my courses for the student. Okay. All right, next move on to the 3 criteria. After the 3 criterion, number 4 is we go back to the material knowledge. The 4 characteristics of the material. That's from the plastic. Okay, so again, let me just recap what you have learned. I'll show you this video. Let me just do a setup. I will turn it to the stereo mix mode.
Injection molding is the primary molding method for thermoplastic materials. The process usually includes the following steps: feeding, plasticization, injection, pressure holding, cooling and injection. Plastic pellets are fed into the injection hopper and then fall into the barrel. Inside the barrel, the rotating screw transports the pellets forward. The heating bands wrapping around the barrel warm up the plastic pellets. As the pellets are moved forward by the rotating screw, they are gradually melted and are entirely molten when they reach the front of barrel. Once enough molten plastic is in front of screw, the screw injects the molten plastic into the mold cavity through screw and runner system of the mold. When the molten plastic is shrinking inside the mold due to cooling, the screw will continuously force the molten plastic into the mold for replenishment to ensure that a complete structural product is produced. The mold temperature controller delivers water or oil into the cooling system to maintain the mold temperature as specified. The molten plastic cools down and then solidifies in less than a minute. The mold opens and the ejector rod moves the ejector pins forward. The part and runner fall and the capture in the tin. After that, the whole process repeats over and over to produce more plastic products.
Okay, welcome back. So, and the video have shown you again to recap some of our study. All right. So now we talk about the 4 important characteristics from the of this plastic material. Now, actually, for me, injection molding is about material processing methods. So, in short, actually, okay, let me turn on my camera. Just switch off. Okay, I'm back now. So now in summary, therefore, the injection molding, what happened is that the process actually involved to heat the plastic. All right. So you heat the plastic in order to melt down the plastic, and then you have to flue the plastic. When you flue through the nozzle, the screw, the runner, through the gate, and inside the cavity, and then you pressure it, right? And then after that, you cool it. So that's it. All right. So what happened to the material is the material will experience the heating, and then fluing, and then being packed, being pressurized, and then cool down to solidify. Okay. So it is very important that the modern and knowledgeable molder, you have to adopt the mindset of processing from the material or from the plastic points of view rather than the machine focused approach. Now, what is the difference between this is machine focused approach means that you set the data into the machine. You command the machine to heat up your plastic. So from the material points of view, whether this heating is totally transferred to the material. So you set the barrel temperature. Let's say you set barrel temperature 200 degrees C, and you have to ask yourself whether your material is actually also achieving 200 degrees Celsius. All right. And what is important? Is the machine more important to heat up to 200, or your material receiving the actual temperature that is required? All right. So you have to understand machine focus means that it's all the data that you key in, but the material receiving this variable here, these are all output data. Okay. So therefore, material know-how is very important for you to conduct this effective molding. Okay, so there are 4 characteristics of the plastic. The first one is plastic temperature. Okay, so now I talk about plastic temperature, not the barrel temperature. You know that in your injection machine, you have a barrel, right? Where you key in, and all this temperature, which is heat up by the heater bands, which is wrapping around this injection machine barrel. So here you can see that we conduct a check, and this is to me is more important, right? Because I want to make sure that whether this plastic has received the desired temperature, right? So you have to imagine sometimes when you key in 200, your plastic could be higher heat or could be lower heat. in order to assure that, you must measure this output information, right? Because after all, in the end of the day, what you are trying to process is a material. Material must receive the required specification, right? So plastic temperature is one of the important characteristic here. And the second one is a plastic viscosity. What is plastic viscosity? So viscosity means that it's a flow resistant, right? So flow resistant, meaning that if viscosity is a high, they mean resistance is a high, and therefore they will flow slower. If viscosity is a low, they can flow faster, right? Flow faster or flow slower is very important because it's a matter of how plastic fill in and to pack, because this involves the flow of the plastic here, right? So here I can show you that. Here I will show you this picture here. Which fluid? I have two fluid here. Which fluid has the lower viscosity?
Which of these fluids has the lower viscosity?
Can somebody type for me in the chat box? Yep. Yep, that's right, on the right hand. Remember I said that viscosity is a flow resistant, all right? So therefore, if they have a lower viscosity, means that they flow faster. So the right hand column, the right hand fluid is having the lower viscosity. Now, the key here is that when the viscosity is changing, you will not able to maintain the same flow rate. Here is the picture that I show you. You see that initially you have a high flow rate, but then gradually the flow rate becomes lesser and lesser, and this is inconsistent. When you have an inconsistent flow rate, you will not be able to get the consistent molding result. So for the plastic viscosity, it's involved the study of the rheology of the plastic. Now, rheology is the science of the fluid flow. All right, this involves the fluid flow study, and we call this as a rheology. So this itself is another discipline of the material. The third characteristic is about the plastic pressure. Since I mentioned that you need to also pack the material. So what is the pressure? Pressure is a resistance to flow. So that means to say that when the plastic doesn't move, it will build up the internal pressure. And for this reason, why we have the one of the function is after you fill, you squeeze more material, you pack the material. Now you need to introduce the pressure to the plastic because of plastic, when they change from the liquid to the solid, it can shrink as much as 20 to 25%. If they shrink more, means that you get the smaller dimension, right? So therefore, you need to provide them this pressure. So here you can see that when you push them in, initially you fill up, and then you have to pack. So you have to pack the material with the high enough pressure. Otherwise, the plastic will shrink, and then you will not get the desired dimension, because it can affect the part dimension. And if you do not pack them sufficiently, they cannot copy the surface finish of the mold. So therefore, it won't give you the right result. And the last one is plastic cooling. And plastic cooling also can affect the productivity of the molding cycle. Because when you look at the one molding cycle, the time spent here, for example, is a mold opening. I have a chart here to show you that these are the time occupied by the various functions in the molding cycle. So here, mold open, and then the part will knock out, and then the mold close again, and then you fill up, and then you pack. Fill is very fast, okay? And then you pack and hold. This will take a longer time, and finally, there is a cooling. So you can see most of the time cooling will occupy more than 50%. So if you want to improve the productivity, 5 ways to give a effective cooling system, and that's one way to improve the productivity. Okay, so here you can see that we have this water pipe here, and this is a cavity where you fill up the plastic, and this is where they go through the cooling phase in the molding cycle. In the future, Jack Ma said that future is a data, all right? So I mentioned to you what data is important? Is it the input data or output data? By matching this important data, then I'm sure that you can produce the same part with the same quality. So input data is actually more important than the, output data. Output data are those results that you achieve. Input are those that you key in. So here we have a input and output. And this is to say that your machine data, for those data that you key in, is not same as the process data. You know that when you want to run the process, you want to make sure that your material receive this information. They receive this heating rate, flow rate, and the pressure, and also the cooling rate, right? Not the machine data. And this is to say that because some machine, you key in 200 degrees C, your plastic may get 200 or even lower or higher. So we do not know unless you measure to confirm it. But another machine, maybe you need to key in a higher temperature in order to get the same output data, right? So matching this data is very important. So output data is more important than the input data. So if you can match the output data, not the input data, I'm sure that you can do a consistent molding regardless of where is the machine located, what brand of the machine. Whether you use a brand A or brand B, as long as the plastic say I receive the same temperature, same flow rate, and same pressure, that I can, and same cooling rate, I can get the same result. Okay, now we go into the quiz number 4. So can Mr. Lim help me to type in this link again for them to find the answer? I want to ask you, which of the following are machine independent parameter? So here you involve output data and the input data. Remember, output data independence of the machine, right? So that means this data is not depends on what machine you use. Okay, so let me see. This is quiz number 4. Which of the following are machine independent? I don't care. That means I don't care what machine brand you use, where is the machine located, but this information is actually representing the output data. So I want you to match this data. Okay, I think majority of you selected number 6. You talk about none of the above. Then 33 is all of the above. Number 1 is part weight. Okay. Right, more coming in. So more coming in. Responses. I need the answer. Think about. I want you to match this data where independent from the machine that you use. Whether you use a machine A, B, C, D, whether they locate in Penang, KL, Starbucks, doesn't matter. But as long as this information must be matching. Okay. Okay, I think majority of you selected all of the above. Okay, back to my slide again. The answer is actually number 1. Why number 1? Because number 1 is a part weight. So for example, you produce a part out, you measure the part weight. So you measure the part weight and that gives you the same quality. If you go to any other machine, if you come up with the same part weight, and that is the material information, and that is your product, and that is your output. Whereas injection speed, you can key in whatever speed you key in, maybe 50 mm per second, or maybe temperature, barrel temperature, you key in 200. So screw position, you key in the screw position where you want to stop the transferring between the fill and the pack. So all these are the machine data actually. Right? Injection speed, barrel temperature, screw position, these are machine data, which is a key in data, which is an input data. So I want you to look for output data. So there are 4 output data, very important. Okay. So let me see, just to make sure that I have. Okay. All right, so then we move on to the last section here, and here we talk about the 5 conditions from the workshop. So I hope you get what I'm trying to convey the message to you. So from the earlier 4 section, now we go into the final session, and here we talk about the step in producing the injection motor part. Now to make an injection motor part, there are many activities involved here. So one of the activity, of course, you always have to start from the design. Yeah? So the product design. So you must design out certain product articles that will be sellable. Okay. And then you need to specify the material. And then you need to fabricate a mold. And then you need to select a machine. And finally, you need to key in all these parameters, the predetermined set of parameters to command this machine to do the job. So the 5 condition, and I realized that the whether you are in injection molding, die casting, extrusion, or semiconductors. So because I teach not only in the injection molding topic, I teach also in others process. But I find that the regardless of the process, the quality and the productivity issue will not run away from these 5 M factors. What are the 5 M? The first M is the product design. As I showed you just now, you must have a product design first. But the design must be manufacturable, meaning that you must be able to manufacture out with the least reject and with the faster cycle time, and also with the better yield. See? And that is the function of the design. Many designers, when they design something, they only talk about the functionality of the part. But that is only half of the job. The other half of the job, you must make sure they are manufacturable. If you're using the molding process, we can call this as a moldable design. It means the design allow you to mold out in a faster cycle time, less material, less reject. Okay. And then we have a material, second M, material must be choosing the right material, material understanding. Mold performance is the third M. And machine selection, you must select the proper machine. And finally, processing method. Okay, and this is why I have invented this concept called the 5M concept learning. Right. So all start with the M. So that involves manufacturable design, and then material selection, choose the right machine, mold, and also the method. So I will explain to you one by one from this 5M factor here. The first one is a product design. So as I mentioned to you, designer normally when they design our part, they thought of the functionality. Okay, but this is only half of the job. Of course, it must be functional, otherwise nobody would like to buy your product. Okay, but the other half is you must make sure they are manufacturability or moldability. If you want to use it, use this molding to manufacture out. So meaning that ability to mold out with the less material, less reject, and the less cycle time. So now from this design factor here, I realized that the main culprit here is because the basic design guideline never followed. And that makes the molding process very difficult to achieve the quality and the productivity. So some of the design guide, such as the rib design, you can see this rib. Okay, so I have a sample. Where is my sample? Yeah, so this is called the rig. Okay, so this is a rig, and then you have the whole design. So some of the hole here, where is the location of the hole, how big size is the hole, and the hole spacing, and then wall thickness, boss, not the boss that you are looking for the job, huh? And then boss are those. These are the bosses. These are the bosses where they meant for the fastening purpose. And then we have surface finish and even the letterings or logo, and plus also the draft angle. So these are the things that you should study, okay? Because design is one important factor to improve the molding quality and the productivity. And the second is a material. From the material, of course, the main culprit here is because of wrong choice of material. When you select the material, you must know what types of material, right? There are many types of plastic in the market, plus also some of the additive and also the properties, how they are being used in the actual application, whether you need to have a corrosion resistant, whether you need to have a heat resistant, better strength to resist the fatigue, and also the molding characteristic that involve the rheology, which is the fluid flow study of this plastic. So usually wrong choice of material involved either is the material properties or the poor quality that you have selected. That is a main culprit from these second M factors here. So in this case, you can see I have a case here whereby the molder uses a soft surface, easy flow acrylic. Acrylic means there is a PMMA for this thin wall concave lens here. And this thin wall lens, you know that when they are very thin means that you need to select the material which is easy to flow. All right, and because of this is exposed to the outside air, outside atmosphere, you expect that the lens is also being rubbed by some of this dusty environment. So at the same time, you need to have wear-resistant plastic, and also you have to choose a plastic which is easy to flow, right? In order to fulfill the moldability, the production, and also to meet the service performance requirement, right? And in terms of the mold, usually when you look for the mold performance, how do you measure the mold performance? The mold that you compare whether this mold, how do they produce the part, whether they're reliable, whether they give a product quality, and you compare the mold cost, whether when you convert into the part cost, how much is this a mold cost, and also the life expectancy. But in short, it means that the mold function, you measure the mold performance in terms of mold function and in terms of the mold reliability. So from this factor here, the main culprit is usually because of mold design, improper mold design, and poor reliability. Poor reliability means that it doesn't last longer. And sometimes new mold may be no problem, but after using for some time, they become old mold. Then the issues start to occur. You have many reject later part because of the reliability issue. So now, first of all, what is the mold function? The mold function involves to ship the part, right? So mold is regarded as a parent. No parent, no children. Right? To ship the part, therefore, you must involve the design of all the fitting channel. The fitting channel include the sprue, right? The sprue design and the runner design, and also the gate design, right? And also you must make sure that the mold is also need to vent out the air, right? So you need to vent out the air. Otherwise, if you have an air trap inside, you will not be able to get a good part. You can burn the material or you can cause a shock molding. Mold is also acting as a heat exchanger. They must be able to cool down, right? Sooner possible, because you cannot use expensive mold to cool down the plastic down to room temperature. So it acts as a heat sink. So cooling system design is very important in the mold. And finally, mold also need to provide the ejection system to knock out the part. And that is a full function from the mold. So here involved, whether it can function or not, the mold involved the study of the mold design. In terms of mold reliability, how long is a mold can last? So that depends on what types of mold material. You know that your mold is made from steel or beryllium copper, or copper alloy or aluminum alloy. And depends on how you fabricate the mold, because sometimes some of the machining work can damage the mold metallurgical properties. And if you choose the steel, you need to make sure that they have been properly hardened. Remember, hardening is to bring out the internal beauties of the mold, to enhance the performance of the mold. And you need to have a good maintenance also. And then how do you stress the mold? So stressing level depends on the design of the mold. If you have a stress riser, high stress point, of course, you can shorten the mold life. And depends on the setup. If you have a misalignment, that is also no good for the mold to last longer. And depends on the material. Some material may be add in some glass fiber where you have a high abrasive, high abrasion rate. So the mold will wear off faster. And then also the machine, right? Whether you're using the machine which is not rigid, for example. So how stable is the machine? Leveling issue, for example. And the service condition. How do you run your mold? How your mold plays into service when you run them abruptly. When you abusively use it, of course, it cannot. It can only shorten the mold life. So this is on the mold reliability issue. So I just try to skip off some of the slide here. I just want to cut it short to you by skipping the earlier slide because I'm running out of time now. So in terms of machine selection, so we have another M here. Usually when you select the machine, because of the wrong choice of machine, when you select the machine, the mold, you must know their capability and you must know the limit of the machine, right? So you cannot machine. A lot of people select the machine based on the clamping tarnish. So this is a clamping system. Obviously, you need to have enough clamping force, but clamping is only one of the selecting condition. Other condition, you need to consider the machine short wave, and also what is your what we call the power source, whether it's from the hydraulic system or whether you're using the electric machine from the driven by the servo motor, and also your machine platen, the parallelism of the machine platen, which is important, and also the some of the control system in your molding machine, whether they have a built-in sensor to measure some of the output data. And also the mold system involve also the cooling system, the hopper drying system, right? So study of the machine specification is important, right? So therefore, when you purchase a machine, usually the machine supplier will give you the full list of the machine specification, involve the clamping tarnish, the power ratings, the short wave, and the control system, dryer system, and also the cooling system. Okay, so and then when come to the processing method, so I found out that inappropriate steps and the processing parameter is a main culprit from this M factor here, from this methods here. So you know that your plastic is actually not truly like a liquid, so they are very thick and they're quite sticky, right? So, and this will cause the material which is not flowing easily, right? So the viscosity of the plastic depends on many variables. It depends on the temperature, depends on the pressure that you set in, the speed you use, the time, and also whether you have a distance, the room distance for them to move around. So therefore, when come to this workshop practice, you actually need to control the temperature, the pressure, the speed, the time, and the distance control. Distance, for example, short distance, for example. So, and a short, what we call the a short volume, where the it move up to a certain value for the screw that allow you to inject sufficient material or not. And these are the 5 weapons for the molder to control, and that depends on the method that you use. So it is just like filling up this bottle of this empty bottle here. How do you fill the water inside without overflowing it? whether you fill it in this way vertically, or whether you place your bottle horizontally, or whether you measure, then you fill. So without overflowing, without spill over. Obviously, 3 methods here will give you a different result. And the best is, of course, you measure first, then you fill, right? So the same thing also in the injecting the plastic into your mold. You don't want to fill them with some overspilling, then you have this flashing. And when you ever inject too much material, then you can have a problem in doing packing later. So many ways to fill. So here is one case study. You can see that the method. So if you fill too much material, inject too much, too fast, too high pressure, then you have a flashing. This is a flashing. Or if you inject too less material, too slow, too low pressure, then you have a this is called a short molding. It doesn't fill up fully, and this is a rib, for example. Or if you fill with a turbulent flow, then you can cause some bubble, right? This is again also not the effective. Or maybe you fill without the effective venting, which is from the mold design. Okay. So therefore, we need to develop a process. We call this is a strategic process. And since I mentioned that the manufacturing is a science, you need to develop a strategic process called the scientific injection molding. And because you have so many parameters, remember you have a temperature, pressure setting, time setting, speed setting, and also the distance setting. Too many variables. You must develop a traceable, develop a standard process, right? So you try to segregate all these data, but you need to have a process development, right? So, and this strategy, we call it scientific injection molding. So, therefore, to learn about this scientific injection molding, you need to study the background of this process, to study the science and insight of this 5M that I mentioned in order to ensure the consistency. So the future, people say that is going to have a lot of challenges, especially with the coming of IR 4.0. And some people worry about whether our job will be replaced. IR 4.0, the ultimate aim is to have an autonomous running of the machine, whether we will be replaced by the robot. But don't worry, robot will never replace the human skill. If you have some of these skills, so let's say that these are the knowledge and skill that the robot may not be able to replace. So the 5M study involved from the design, and make sure the design is moldable, the study of the material, study of the mold tools, study of the machine, study of the method. Right. So I break down here this method, for example, it can be many methods to make the parts out. It can be many material for you to use in the manufacturing. If you talk about injection molding, of course, we involve the plastic. Of course, when the mold, you use steel, you have to study some of the ferrous material. If you use aluminum alloy or the copper, then you involve the use of the non-ferrous. So these are critical skill and knowledge in order to secure also your employment, and to also make sure that you can help to improve the quality and the productivity in the molding process. So I want you to be trained to be a multi-skilled workers nowadays. Single discipline is not effective anymore in order to troubleshoot the problem effectively. And this is a reason why the MBOT, the defined engineer, is a design discipline, the base profession with academic engineering discipline degree. Whereas the technologies is a multidisciplinary technology. So if you can acquire all this 5M knowledge, you are no longer narrow to only one specific task or specific skill. With this 5M knowledge, you can also fill up some of the vacancy in the various technical departments. And remember, the overall manufacturing variable, manufacturing quality, productivity, is not depends on a single factors. It depends on all these 5M. They must bring them together in order to achieve the final quality and the productivity. And also remember, technical solution is not always a one-sided. You need to optimize. So here you can see that you have a temperature control, pressure, the speed, the time, the distance, and even some of the material hardness. So you can see it cannot be too low, it cannot be too high. You need to optimize. So how do you optimize? For example, if the temperature is too low, of course, you cannot melt down the plastic, you cannot flow it. If the temperature is too high, you may overheat the plastic, you destroy the molecular chains, which is no good for the product. So you need to control. You need to narrow, you need to find the best optimized range, right, to build this robust working window for your process. So knowledgeable staff is therefore a key to successful injection molding. So the solution is not always a one-sided. If you always go to low, I mean, you solve a lot of problems. You need to crack your head to find this optimized. But in reality, cannot be too high, cannot be too low. So therefore, I have, based on my experience, I have invented this so-called manufacturing inside skill training to address the 5M study. And I find that this is really a missing link study to develop these knowledgeable workers and to promote the scientific manufacturing. So if you're interested, you can always log on to this link here. Okay, so maybe later on you can ask from your lecturer, from the MC, from the moderator, Mr. Lim, he will give you some of this link if you want. Then you can log into it, those other courses if you're interested to attend. Okay, the final question, the final quiz here. Can Lim type? This is the final quiz. Which element is not included under the 5M concept learning? Okay, so this is quiz number 5. That's 5M. Okay, so I can see majority of you very fast. Yes, there's a lot of people coming in. The result, so 86% choose number 3 is not under the 5M. Okay. So men, nowadays it's not men. A lot of ladies also involved in the injection molding. It would be unfair to talk about men. So I just name it as a method that you use. All right, so 5M involve, the first M come from the product design, must be manufacturable, right? And then the second, the mold, and then select the machine, select the material, and the processing method. So the answer is number 3. We didn't talk about men. We didn't talk about money. Some say that M is a money also. There's no money, no talk. Okay. All right, so majority of you, they can score the right answer, which is the number 3. It's not the M. All right, so let's go back to the slide again. Okay, that's all from my this morning webinar on the topic of this injection molding. So thank you very much for your watching.
All right, thank you, Mr. William Lee.
Yep.
So we'll go ahead and take some time for question Q&A session. So anyone have question to ask?
Sorry that I am supposed to allow you half an hour for Q&A, right? Oh, let me check. My time is until 12 or actually 11:30.
Yeah.
But they're still with me. These people still 99, so 2 already quit. I'm sorry. I thought my session lasts until 12. So you allow half an hour for the. Okay, if you don't mind to stay with me, I'm trying to answer for you.
So any question from?
Okay, how do I present now? Okay, let me switch back to my. Am I still sharing or not? Am I still sharing my slide now?
No.
No. Okay, so
No.
that means I quit the slide already. Very good. So let me turn. Okay, any question from the floor, from the audience? Am I running too fast? Can you able to catch up? Because I'm trying to share with you as many information, as many knowledge as possible. Yes, I have a question coming in. What is the specific viscosity of the plastic molding? What I can say is, of course, viscosity is a measure by the unit of Pascal second. Pascal second. So you can imagine that if I'm not mistaken, I think the viscosity of the plastic is about 1,000 to 10 to power 5 Pascal second, which is much higher than the honey. Can you imagine honey? Honey is quite sticky, right? So therefore, they are higher than the honey. So they are just, you can imagine they are just like our toothpaste. So for the toothpaste, if you want to squeeze out the toothpaste, you have to apply the force, right? So therefore, the viscosity of the plastic is rather high. Of course, they're lower than the glass. You know, when people blow the glass viscosity is much higher, even though they are in a molten form, but they still can exceed in the semi-solid condition, right? So that's the reason why the viscosity of the plastic are high. And furthermore, you need to flow them through the small channel. You need to apply the speed. I can tell you that by using a higher speed, all right, so you can lower down the viscosity. And of course, a higher heat, when you make them flow, you can also lower down the viscosity. But when you really want to measure them, you have to conduct a viscosity study, which is one of the scientific molding study. Okay, so that's my answer. And then we have a question. You are interested for the training from McLaren, so may I know the specification of the training, especially the schedule? Well, most of my course is actually currently offered to the industry people. All right, so of course they are chargeable, and then this company, they send their staff to attend my training, and they can allow to claim back from the HRDF fund. But as a student, I'm afraid that you have to pay for your own. But as I said before, if you're interested for some of the program, we can discuss with you have a CEE or what? Continuous CPE division, right?
Yes.
Yeah, you can also, you can propose. We can conduct a survey. I can give it a full list of my training program, and I will try my best to give it the best rate. So I know that the students is difficult to pay for the high fees. My fees is very high actually in the public training. Okay, but I promise we can discuss with your lecturer in the later on to offer my service if you're interested with some of my program. Okay. So what about the metal? I have a question. Metal injection molding with our technology now. We do have a metal injection molding small metal part, high complexity, but with a large metal part be available for injection molding compared with die cast. Well, I think I do not have much information about the metal injection molding, but this seems to be also one of the new technologies whereby you can produce the methods using the injection molding process. But basically, you just blend with some what they call the amorphous plastic, okay, or the thermoplastic. But you can expect that the shrinkage will be much higher, because in the end of the day, you need to remove this plastic and then to get the methods, to get this metal out. Therefore, you also involve some heat treatment process after the metal injection molding. But in the future, will that be able to replace to make the large parts or not? And this is yet to see. but I will be keen to know more about this as well. There are some people asking me to conduct this metal injection molding, but at the moment I don't have a cost offer for this because the market demand is still low. But this is one interesting subject that I might like to develop also in the future. Okay. Thank you, sir. Yes, you're welcome. So plastic has how plastic has a different color. Yes, they add some of the color pigment. It's just like how do you make your water become sweet? You add the sugar. All right. So you want to make the color in the plastic, you need to add this coloring compound. Okay. This is also one of the additive. And usually when you add the additive, remember, it can also make the plastic, generally they can make the plastic flow easier. Do you do a silicone too? No, I don't do this silicone because silicone is a thermoset plastic. Yeah, there are some people who are using thermoset plastic, but again, the demand is not so many, so I have not developed any silicone injection molding. But again, this involves the another types of plastic. We have one participant I noticed from Texas Instruments. I'm not sure whether they are using a transfer molding. If they are using a transfer molding, then they use a thermoset plastic. But for for injection molding, normally you use a thermoplastic, which is a recycled plastic where you can melt them down and then to remelt again. So there's a question saying that they are asking nowadays a lot of people are reducing the use of plastic to save the environment. How is your company cope up with this? Now my company is not producing any part. I'm only provided training to them. Of course, we encourage the use of the recycled plastic. But again, some of the product you might not able to allow to use too many recycled plastic because sometimes the recycled plastic, it can also affect the molding characteristic, and it can also contaminate your product, especially in medical product. So in medical product, normally they use a 100% virgin plastic. Any idea how to calculate or minimize the cooling rate for actual design by the third-party software or guideline design based on visual quality inspection to calculate? And minimize the cooling rate. Yes, I think the cooling design is one of the function for the mold maker by right, because cooling is considered as a thermal design. So thermal design, sometimes you need to calculate how fast it cool, how much the flow rate and so on. And there is a guideline, definitely. I think there is a formula to calculate. And offhand, I do not have this information with me, but you can always search from the internet. And for the actual practice in the workshop, normally I advise the people when you want to monitor the cooling rate. So it's best that you install the flow meter. So that from the flow meter, you can see that how fast the cooling rate, and then you can see sometime if the cooling line is corroded, it might also affect the cooling efficiency. Okay, so there are some guidelines in the mold design. I think one of my topic, one of my mold design topic, I will address this, but it involves some complicated calculation. You need to understand the thermal properties of the plastic, not only plastic, but also involve the mold material. How fast the mold can transfer the heat. And that will be addressed in one of my mold design topic, actually. Okay, you're welcome, Vivian Wong. Okay, so then what is the design consideration for manufacturability? As I mentioned that the design here involved for example, the draft angle, right? You must know that how much draft angle is required, and then the reed thickness, the radius, the hole. All this will have some basic guideline actually. Okay, so you just follow the basic guideline, and then you have to consider some of this in order to make it moldable. Okay, there are definitely some guideline, of course, but I do not have it offhand for you. Yeah, all this will be addressed in my another subject called the mold design. Okay, so I have another question coming in. Is Malaysia government encourage a riot? What? use a biodegradable plastic to reduce the usage of a conventional plastic? Yeah, of course, the not only the government, of course, as a responsible citizen, we have to make good use of the plastic actually. But I feel that the sometimes we do not blame to the plastic actually. We only blame to the people. How do you use the plastic? Are you encouraging the? If you encourage to have a good use of the plastic, you should also emphasizing. We should also try to use some biodegradable and try to recycle the plastic as possible, especially for those commodity product, for example, like those cup, bottles, and so on. If we can reuse it, then it's a better. And sometimes we can also use recycled plastic maybe for other area, for example, like our polymer currency notes. You can use some of this recycled plastic. How is the flow analysis assist in the mold design? The mold flow analysis software. Yeah, okay. This software nowadays can assist or can facilitate us to design better in order to give us a simulation. But bear in mind, all this software can only facilitate, but it still depends on how accurate is this simulation. So, and that means that it still require you to key in the important data in order to simulate it to the real world situation so that you can see how the plastic will flow. Definitely, of course, it can help, but all these melt flow analysis software, usually they're very expensive. What is a common defect that usually occur in injection molding, and how will you usually solve it? Common defect, well, sometimes, for example, like flashing. I have a case here, you can see that this one is purposely, I purposely make it flashing. You can see that this is a common defect, flashing. And then you have a burn mark at the end of this rib here. This is a burn mark, okay? Short filling, burn, sink mark. So these are some of the common defects. How do you address it? So now I have to go back to the basic. I have to examine the design features, and I have to know how they mold it, using what temperature, what pressure, how do they fill it, how do they pack it. Again, I go back to the 5M. So, and I try to trace out which M is a major root cause to cause this defect. All right. So bear in mind that, as I always mention to my participant, quality control, you can pinpoint the defect. But if you want to solve the defect, you have to go back to the basic. And the basic, you need to understand what are the factors contribute to the molding quality. So we have to look at the design, we have to look at the methods, mold machine that you select, whether they give you a sufficient speed, sufficient pressure or not. Okay. So another question is, what is the common defect that usually occur? Okay, this one I already answered. Okay, I think I've answered all the questions. There's no more incoming question. And we still want them to fill up the feedback form, right, Lim?
Yes. I will attach the link in the chat box. Hold on.
And I noticed some of them already quick.
No. Hello, Mr. Lee. No worry, we will send the feedback form to the participant through the email as well.
Yes. Okay, Lim already typed out the link where you have the feedback form. I appreciate if you can fill up the form by reading your evaluation. Then I will try to improve my future presentation for the benefit of all.
All right, I think we have covered all the questions. Okay. So, Mr. Lee, is there anything else you want to cover before I wrap up?
I think not much from my side here, except that I apologize if I have go through my presentation too fast, and I know that they don't have a notes, so, and that's the reason why the okay, thank you for Mr. Koo also. I mentioned about thank you. Okay, so thank you very much. No problem. There's not much from my side here, except that I wish that you have keep yourself, stay safe, and stay healthy. I hope you have enjoyed the show.
All right, thank you. It was a very comprehensive webinar on injection molding. So we appreciate you being here. Thank you, Mr. William, and thanks again for joining us for today.
Okay, you're most welcome. Thank you
We'll
very
see you
much.
next time.
See you. Bye bye.
Okay.
Thanks, Mr. Lee. Thank you so much.
Uh,
Wonderful, wonderful. Thank you.
You're most welcome.
Yeah, thank you, William. Yeah.
Bye.
Hi.
Bye.
You're most welcome. Bye.
Thank you. Thank you. Please help to fill in the feedback form so that we understand we can get the feedback from the participants, and then we can have a chance to improve and right? Because this is the first time we organize industry talk with the professional technical trainer. So we need your feedback to help us to improve in future. Yeah.